Hello, my name is Yashikharan, anak lelaki Baskaran. My matrix number is AN190120. Today I'm going to talk about my final year project with the title of Absorption of Heavy Metal Lead using Floating Aquatic Plants Duckweed LEMNA minor. My supervisor is Dr. Noramida binti Hamidun. We are from the JTKA department of the Faculty of Engineering Technology in UTHL. Contents of this presentation: Chapter 1 will be the introduction, 2 literature, 3 methodology, 4 is results and discussion, and finally is the conclusion. Now for the introduction. The study was done in order to determine the chemical properties of surface water while also investigating the effectiveness of duckweed LEMNA minor in absorbing heavy metal lead. Sungai Panchor is a river that is situated at Panchor, which has become the study area for our study, and it is a source of income for the people, the residents living around Panchor. The river is used mainly for fishing, daily needs, and also recreational activities. Duckweed is introduced as an environmental friendly and cheap alternative for surface water treatment. For the next chapter, it is literature. Pollution from industrial discharge, agricultural runoff, and urban stormwater can introduce harmful chemicals and heavy metals into surface water. These heavy metals are unsafe for fishing and other recreational activities like swimming and also drinking. Heavy metal contamination in surface water refers to the presence of excess levels of metals such as lead, mercury, cadmium, and other in streams, rivers, lakes, and other bodies of water. These heavy metals can enter the human body and aquatic life's body by ingestion, retention, and other means. They are toxic to living things. Some of the impacts of heavy metal contamination is toxicity to aquatic life, damage to the food web and ecosystem, and the most important of all, the reduction of water quality. Heavy metals can accumulate in fish and other aquatic organisms, leading to health risks for humans who consume them. So for phytoremediation is the use of plants to remove pollutants from the environment. In this case, duckweed LEMNA minor is a type of aquatic plant that has been studied for its potential to use in phytoremediation. Duckweed has been shown to show an effectiveness in removing heavy metals such as lead and cadmium. The plant's ability to absorb these pollutants is due to its high surface area to volume ratio. Duckweed does not only absorb heavy metals but also is good in removing other types of pollutants such as nutrients, organic compounds, and pathogenic microorganisms. The use of duckweed in phytoremediation has several advantages. It is a fast-growing plant, it can be easily propagated, and it can grow in a wide range of environment conditions. These include rivers, lakes, slow-moving water, and it does not require extensive inputs of water, fertilizers, or pesticides. Next, we go to the methodology. First is the site investigation and water sampling. As said before, the site is Sungai Panchor, so I choose a area where there is a bridge, so there's easy access to the water, and using a bucket and rope, I collect the water samples and mix it into the container, so this will form a composite sampling. Then the samples were kept in a cold place to retain the parameters, retain the chemical bonds inside the water sample prior to testing. Next, for the laboratory experiments, the experiments that were done were pH, turbidity, dissolved oxygen, and also heavy metal lead. For the phytoremediation process, the water sample was poured into a rectangular container, and the duckweed was put into that container with the sample, and it was left for 9 days where it was getting constant sunlight and made sure the container was not being moved, so the water was staying stagnant. After 9 days, the water sample was brought back to the laboratory for experiments on the same 4 parameters, which were pH, turbidity, dissolved oxygen, and also lead. The results were then wrote down as before and after. Each parameters were tested 3 times, and the average was calculated. For chapter 4, which is the results and discussion, the parameters that were tested were pH, dissolved oxygen, turbidity, and heavy metal lead. The initial reading for pH was 8.30, and the final reading was decreased to 5.31. For dissolved oxygen, the initial reading was 0.96 mg per L and was increased to 8.65 mg per L. As for turbidity, the initial reading was 7.54 NTU and decreased until 1.85 NTU. And finally, for the heavy metal lead, the initial reading was 69.67 microgram per L, and it decreased to 44.67 microgram per L. The removal percentage of lead is 35.88% over the course of 9 days. This shows that the water sample after the process of phytoremediation is in a good quality. High DO is important for aquatic life to live, where this is important because Sungai Panchor is one of the places where fishing activities are very big, and low turbidity and low lead concentration causes the water quality to increase as the same. So, through this study, we can conclude that duckweed, LEMNA minor, is a suitable option for the absorption of heavy metals with the removal percentage of 35.88%. The water quality is also improved after the process of phytoremediation. This is evident in the reduction of turbidity and the increase of dissolved oxygens. For further research, experiments should be handled in a way where there is no disturbance in the water sample, and the duckweeds are always getting constant sunlight and to yield more accurate results. For practical solutions, we can build a cage or a fence around the duckweed in the river so that it won't be flowed by the flow of the river or be disturbed by waves, by boats or anything. This will also yield more accurate results. At the same time, convince more people that this method is a very useful method for surface water treatment.